Morning, everybody. To day 19 of Math 133. Can everybody hear me okay? All right, good. So today we're going to look at the Chapter 8 review. Um, Make sure you do your lecture notes. So 9.1, so we're starting Chapter 9 lecture notes. On Tuesday, you're going to want to make sure you've got your M&Ms and your Skittles ready to go. So next week on Tuesday, we're going to do the candy project. As I said before, you will get to eat the candy afterwards, so you don't have to go out and buy something that you won't get to have. But um, so for the candy project, you need to have somewhere around like 5 ounces of M&Ms, somewhere around like 5 ounces of Skittles. Uh, if you uh, so you are allowed to like combine candy. So if you uh, get a bunch of fun size bags. You can open like a couple of those, as long as you get like, you know, somewhere like 5 to 10 of those. Yeah. So that's for Tuesday. Uh, on Thursday the 6th, watch out for watching your remind because we might be starting that class at 10 a.m. Got stuff going on that morning, but I'll send you a message and remind if that ends up being the case. Um, okay, so let's go to our chapter 8 review. Today is on page 471 in your course pack. Page 471. Now the so chapter 8 was all about the central limit theorem. And in the central limit theorem, we talked about sampling. Um, so if you have a population, you can measure the mean and the standard deviation, or possibly you might be looking at a proportion of something. So like what percent of people, you know, have their driver's license or whatever. So that's a proportion. Um, and when you have a population, uh, that population is usually very large in practice, okay? Millions of people, or, uh, you can't measure the entire population. So we take a sample instead, and we use the mean or the proportion from that, from the sample, to approximate what the population mean or proportion would be. So in chapter 8, we talked about the central limit theorem for means. We also talked about the central limit theorem for proportions, okay? And for the most part, they're very similar. There's some minor differences, okay? But anyway, so for those, um, for chap if you satisfy the central limit theorem, then you can say that your sampling distribution is approximately normal, right? So it doesn't matter what the original population was. The original population could be very skewed, but that's okay. Um, anyway, so for chapters 9, 10, and 11, we're going to be using some of the things that the central limit theorem lets us do, but we're going to be kind of combining things. We're going to be talking about means and proportions. And so you're going to have to pay attention to whether you are trying to measure a population mean or a population proportion. Okay. So just be aware of that. Okay. Instead of having separate chapters, we kind of combine things. So just watch out for what we're trying to measure. Okay. Anyway, for question number 1, you're just going to fill in the symbols for all of these different things, depending on whether it's a population or a sample. So no big deal there. The following 3 distributions are the sampling distribution. The sample means 250 samples taken with 3 different sample sizes, 5, 10, and 20. So one of these was for 5, one of them n equals 10, and one of them n equals 20. Um, and uh, So after you've done that, explain how you can tell which graph is which. So this is for sample means, and you'll remember that the spread of your distribution is going to be this formula here, S divided by the square root of n. So when n is large, it means that your spread is small. So explain how you can tell which graph is. So a large n value means a small spread. Okay. So that's going to be your hint on how to do part A. Okay. As well as part C and D. Okay, great. So let's move on to the next page. Page 472. A sports analyst gathers a random sample of NBA players from the 2024-2025 season, number of games played. So calculate the standard error of the sample mean. So standard error of the mean is this crazy formula. So it's standard error of the mean. I know that looks like a bad word, but or inappropriate, but yeah, standard error of the mean is equal to the standard deviation divided by the square root of n. Okay, so you're going to want to calculate. So they gave us the numbers. You'll plug those in, calculate it for us. Okay. Question 4. The average BMI for adults is this. Standard deviation is this. Weight loss researcher gathers a sample of 72 random adults, 250 million in the US. Verify the conditions of the central limit theorem for means are met. Okay, so we're going to be doing this kind of thing, verifying that the central limit theorem conditions are met. We're going to be doing this quite a bit in this chapter, as well as in chapter 9, 10, and 11. And that's because we need to make sure that we are satisfying these three conditions, because if we do have these, then we'll be able to do a lot of other things, okay? We'll be able to use all the superpowers that a normal distribution has, okay? So the conditions are random, independent, and normal, okay? Random, independent, and normal. Okay. All right. For random, so for this, all we have to do is we have to check if somewhere in the problem it says that we did a random sample. So right here, we gathered a sample of 72 random US adults. So yes, that was given to us. Okay. As I've said before, uh, this part is actually the hardest part in practice to make sure that your sample is random. But for the class, it's the easiest part. You just have to check and see, oh, does it have the word random? Yes, it does. Good. We're done. Okay. Um, for independent, uh, that means that the sample has to be not too big. Okay. And usually that doesn't matter. Oh, this is page 472. Um, so for independent, it just means that your sample is independent of the population. Okay. And so for that, we need to show that the sample size is less than 5% of the population size. Okay. So in this case, we have 72 people in our sample, and we need to check, is that less than 5% of the population size? So the population size, so 72 random US adults is our sample. Our population would be all US adults. So how many US adults are there? There are 250 million. So 250 million. Okay. So we need to check and see if this is true. Is 72 less than 5% of 250 million? Well, 5% of 250 million is how much? Can somebody calculate that for me? What's 5% of 250 million? In your calculator, 0.05 times 250. Yep. It is 12.5 million or 12,500,000. Okay. Is 72 less than that? Oh, yes, absolutely. All right. 72 is much less than that. Okay. So usually the independent part is the easiest part in practice. Um, now, by the way, we did it this way where we were checking n is less than 5% of population n. Okay. Um, so if you, so 5% is 1 over 20. If you multiply both sides here by 20, you get this. 20n is less than population size. 20 sample size less than this formula right here and this formula right here, 5%. These are the same, okay? And you can use either one, okay? Sometimes it's easier to do this one, 20 times n. If we did 20 times 72, we would have gotten, uh, let's see, we would have gotten 1,440. That might have been easier than doing 5% of 250 million. It's up to you. So basically, they're the same formula because all you do is you multiply both sides by 20, and 5% of 20 is 1. So, um, okay, that looks good. Lastly, we need to check if it's normal. And by that, we mean we need to check and make sure that the sample size is large enough. Okay. So for the central limit theorem for means, all you have to check is your sample size bigger than 30. Okay. Now that's for means. If we're doing your proportion, then you still need to make sure your sample size is large enough. Okay. But to do that, you also need to check with P and Q. Okay. So in other words, you take your sample size times your uh, expected proportion and then times Q, which is 1 minus that. That needs to be larger than 10. Okay. So the reason why this is because if you just do a sample size of 30, but your proportion is very, very small or very, very large, um, then just being bigger than 30 is not enough. Okay. So we can talk about that when we look at those, but just pay attention to whether you are looking at means or proportions for this part of the question. Okay. In this case, we're looking at means. So all we need to do is we need to check is n greater than 30. So yes, 72 is greater than or equal to 30. Okay. So three yeses. We got yes on random, yes on independent, and yes on normal. That means that we did verify, we did check, and all of the conditions of the central limit theorem are met. Okay. Because of that, we can use a normal distribution for the sampling distribution of sample means. So for part B, describe the sampling distribution, give the shape, the center, and the spread. Okay. Um, so the shape of the distribution is going to be normal. Okay. What that means is it's going to look like a bell-shaped curve. It's going to have a tail to the left, and then it's going to go up, and then it's going to have a tail off to the right. Okay. The center is where the mean is. Okay. So they said that the mean, the average, they didn't say mean, but that's fine. Mean and average are the same. They said the average was 30.7 kilograms per meter squared, whatever that means. Um, the key here, all you really need to know for this is that your spread, sorry, your center is going to be the same as the average of the population. Okay. Lastly, the spread. So this one is also a little bit different depending on whether you are looking at means or proportions. Okay. So if you're looking at means, which we are in this case, the formula is S divided by the square root of n. Okay. If you're looking at proportions, the standard error is square root of p hat times q hat over n. Okay. Or p times q over n if you know p and q. Okay. You don't always know p and q. Um, so this actually is the same as the formula for means because the standard deviation is going to be the square root of p hat times q hat, but I'm not going to make you write those out. Basically, it's one of these two formulas. Okay. In our case, the spread is the standard error. Standard error of the means is S over the square root of n. Okay. Which is, let's see, the standard deviation they gave us was 6.1. The n they gave us was 72. Can someone calculate that out for me? Should be close to 1. Oh no, it should be less than 1. 0. 6.1 divided by the square root of 72. 7189. Thank you, Andrew. Don't forget our units, which are kilograms per meter squared, whatever that is. Okay. All right. So that's it for number 4. So didn't give you hints on that one. I gave you the whole thing. All right. Page 473, question 5. The following three distributions are of the sampling distribution of a sample proportions with 1,000 samples taken with 3 different sample sizes. That sounds confusing. All it really is saying is one of these ends is 40, one of them is 80, one of them is 120. Okay. So you're going to figure out which one is which. Okay. And again, how can you tell which one is which? So when you have a larger sample size, means that your graph is going to have a smaller spread. Okay? When we say smaller spread, it means it's going to be thinner and taller. Okay. All right. Well, it's pretty easy. I'm going to move on. Question 6. Um, let n equal this, p equals this. Assume it's random independent sample, and you have this. So compute standard error of the proportion. So that formula is on page 189. And it's right here. Standard error of p hat, and it's the square root of p times q over n. Okay. So you're going to plug in what your p-value is. You're going to plug in what your q-value is. Calculate it out. Okay. All right. Question 7. A study found that 39.5% of US teens have their driver's license. Okay. It's a lot less than I would have thought. I guess when you say teens, like you can't have a driver's license at 13 or 14, I guess. So I would assume that you would only count from 16 to 19. But anyway, a random sample of 224 US teens is taken. Verify the conditions of the central limit theorem for proportions are met. So again, we need to check, is it random? Is it independent? And normal. Okay. And the normal one is going to be different depending on whether you're looking at means or proportions. Okay. If all three of those are yeses, then our shape will be normal. Then our center is going to be whatever the p-value is, and then your spread is the same formula from question number 6. Okay. Okay. That's all the hints I have for you this morning. So let's go back through and fill in the parts we skipped over.